This is K8BYP's video on the solid-state amplifier mystery. Hams have wondered and practiced the idea that they can make tube amplifiers work, but they can't make solid-state amplifiers work because the solid-state amplifiers blow up. They have no idea why. Same antenna system, works on a tube amp, must be okay, huh? Well, no, the antenna system is garbage and is the reason that the solid-state amp fails very often. There's one other class of cause for that, but the big one is a grossly out-of-tune antenna system. Want to email me, K8BYP _ between the characters at itll.org, not ARRL. 1 watt. 1 watt in circuit theory is divided by the product of voltage times current. 1 volt on the left into across 1 ohm is 1 amp. 1 volt times 1 amp is 1 watt. Exactly the same power with 1,000 volts across a resistor is 1 milliamp current. 1,000 times 1,000th is 1. Exactly the same watt, radically different systems. In contrast, the left case, the transistor 2SD1455 on the left, and on the right, the heavyweight vacuum tube 17JB6 out of old granddad here. A vacuum tube. Maybe about the same dissipation in each, but radical difference in size and technology. The tube on the right can withstand very high voltages. The plate voltage specs for that JB6 are about 6,800 volts positive and 1,500 negative. This was used in horizontal output applications in televisions for a high voltage power supply. Transistor on the left that transistor may be 45 volts, maybe 50. And I don't know, peak collector current may be 25 amp. I don't know exactly. You can look it up. 2SD1455. But notice the cases are inverted. High voltage on the left and very low current on the right. Low voltage on the left and high current. And there is one of the roots of the problem. Transistors are extremely susceptible to overvoltage destruction. There's the 1970s HW7 CW transceiver that I built in 1976. And I blew up the front end MOSFET because I didn't follow the instructions. I took the shorting spring off, and then I bent the leads and I soldered it in, and I destroyed the MOSFET with electrostatic discharge. The early, I think it was the emitter coupled logic integrated circuits, were very susceptible to overvoltage damage. Even voltage ringing from inductance could destroy them. Had a limit of, I think it was 20 volts, not 20 and a half. Over 20 volts, they turn into French fries or pommes frites. So what's that got to do with ham amplifiers? The first case, I talked with Ham in Tennessee, who was just beating his head against the table trying to figure out why his commercially made ham solid-state amplifier had lost a set of finals. They'd been replaced, I think, twice, and kept blowing up. And by the way, we discussed this on CW at length. And we finally drilled down to the admission that the power supply ran away to about 60 volts, and that is death on the transistors. Because I think they were rated at 55, not 60. 60 is boom, and it doesn't take any current. So to speak, excess voltage can simply pull the junctions apart. Almost no current and instantaneous damage, one time, and that's it. If you're lucky, the transistor will simply grossly fail. If you're unlucky, what will happen is punch through and leakage. Then the leakage mechanism increases like making a hole in a water dam. And over time, And this is what was happening in his amplifier. It would come on and just slowly overheat and grossly overheat and cut out. That's either a bias problem, the bias has become unstable, or it's punch through damage, and probably in his case it may have been both. The other thing that kills solid-state amplifiers is excess high voltages on the antenna system from a grossly out-of-tune system. There's a transmission line symbol. When the line is matched, voltage and current are K, constant. We say the line is flat. When it's not matched, there might be a sine wave representation of the voltages and current, and they're not in phase. And the guilty parties here are the so-called fake antenna tuners, which are not, and that's a bird that's not called an SWR meter, but you know what they are. Well, there's one in front of the Drake. That is not an SWR meter, and I have videos elsewhere on this channel explaining why that's not a tuner and why that's not an SWR meter. And the problem is building a grossly screwed up antenna system with an out-of-tune dipole and twin lead and baluns and tuners and pretending like that's an all-band antenna. Yeah, it sure is a 2 to 6 to 1 SWR on all bands, which is completely unacceptable. But the problem is observing a high SWR at the transmitter and the delusion that turning the knobs on that box will somehow fix that, and it won't. Why, sure it did. The SWR reads 1.2 to 1. No, it does not, because that cannot read SWR, standing wave ratio, at a single point in the transmission line. Measuring the ratio requires two steps: finding the minimum and maximum voltages or currents on the line at two different points and then measuring them. You're not going to do that with coax without extreme trouble. It was much easier with open line. The problem here is, and even the CB radio operators know this, that there can be an apparently low SWR near the transmitter, but extend the transmission line and the reading changes. That's because the line is not tuned. There's an SWR, the line is reactive, and the voltages and currents are out of phase, and it's possible to adjust that fake tuner so that fake SWR meter, which is really reading forward and reflected current, read a minimum. It's been adjusted so that a low current exists where the meter's reading, and that gives the illusion that there's a match on the antenna, and nothing can be further from the truth. If something like this happens, where the horizontal dash line is 0 and the vertical dash line indicates a point in the transmission line where current is a minima, the voltage might be a maxima, and the voltage might be several times higher than it should be. And back to the proportionality. For the same unit of power, it can be expressed as a very high voltage and a very low current. And if that happens here, then there can be extremely high voltages, bad enough to actually arc over air variable capacitors. And I have an MFJ tuner that did that. I foolishly tried to load it on 160 and arced over and damaged the air variable. If that occurs, and if a significant amount of energy is not dissipated by the transmission line being reflected back, which is the next problem, because of destructive interference, much of the reflected power is dissipated and heats the transmission line, so the mismatch at the antenna is far worse than you can imagine by sitting in a ham shack. And that's why most of us need amplifiers, because of screwed up antenna systems. But if that happens, when that high voltage reaches a transmitter, it's coupled through whatever output network there is and transformed into the collector of the transistor or the plate of the tube as a high voltage. With the JB6 tube and the TR3 properly matched, there's roughly a 220 volt AC swing. On the antenna jack, it's a 620 volt power supply on the tube. It might be, I don't know exactly, a kV peak to peak. maybe 2 at the most, on a tube that can withstand 6800 peak. Transistor can't take it. The transistors are run in solid-state amps at probably 50 volts and probably 5 to 10 volts below their absolute maximum where they're destroyed. And along comes that, and that's the end of the transistor. Nothing wrong with the amplifier, the antenna system's at fault, and it didn't show up on that. And that's what is quite likely accounting for damage or destruction of the solid-state amp. What causes the problem that it never works right again? Replace the finals, they keep going boom. Well, keep using the same screwed up antenna system, what do we expect is going to happen? But there's a hidden gotcha in these solid-state amplifiers, and that's the transformers. When the transistor in the solid-state amplifier is damaged, particularly shorted, and sometimes even on a proper match, there'll be an open junction. If there's an open base emitter and no signs of overcurrent, then it may be okay. But it is absolutely mandatory to replace all the finals. Do not just change one, because they're going to be in series, and an overcurrent through one is an overcurrent through both. And there may be more than high enough pulse voltages here to damage both, probably based on collector base breakdown. And if one fails, there's likely to be a high enough current to damage the other. Don't replace one. If a couple $100 in transistors is too much, ham radio is not for you. Try CB. But in series with those transistors is a transformer. And those transformers are easy to damage also. They can only take so much current before the flux in the core literally damages the core and can possibly short the windings. And that transformer is not usually replaced or suspected unless it's charred. But if there's a catastrophic fault, it's imperative to replace one or both the transistors and at least the output transformer. If you got to take the old transformer apart and make one, do it. In a catastrophic breakdown, the input, the transformer to the base or the gates of the amplifier devices might have also been damaged. So if it's a good high-dollar amp, it's necessary to replace all that, or continue to have long-term problems. It's also quite possible to have a catastrophic fault in the amplifier, which also damages the power supply. Fix the amplifier, put the damaged power supply back on it, and blow the whole thing up again. So, tubes, known for taking a lot of abuse. Transistors won't put up with it for a millisecond. So there you go. Long story short, no excuse for tuners in the ham shack. Unless, like those L networks, they are there simply to match a correctly tuned 75 ohm antenna system to the 50 ohm. All our transmitters are 50 ohms. That's the only exception. K8BYP out.